Continuing with calculator, this is number 33 of the multiple choice cumulative review. Selected values of a twice differentiable function. Again, we see this word a lot here, smooth curve. Order pairs from g of x are shown. What is the value of the definite integral from 0 to 3 of g prime cosine squared 2 g of x plus 1 dx? Now, even though this is a calculator problem, this form is really too messy for us to do anything with calculator. Right now, there's things all over the place. We can't do this form in the calculator. So let's do this. Maybe we can get this to be an easier or a more manageable form that we can then use our calculator for. One thing that stands out is, well, what if we go after U substitution? U substitution will allow us usually to take a messy expression and push it into a more compact form. So I notice parentheses here, so I'm going to target that parentheses, 2g of x plus 1. Let that be the u value. The derivative for 2g of x plus 1, 2g of x becomes 2g prime. Plus 1 goes to 0. And then dx, if I cross multiply, dx becomes du over 2g prime. And then we make our substitutions. Integral of g prime stays initially. Cosine squared u, and then the dx gets replaced with du over 2g prime of x. Now, once I make these two substitutions, so I highlighted, I underlined it in red. These are the first two things that I want to replace. So this gets replaced with cosine squared u, and then dx gets replaced with du over 2g prime. And now we see something that is helpful for our next step is we can see numerator and denominator matches and cancels out, and then we push that 1/2 or that 2 out in front as 1/2, we're left with 1/2 integral cosine squared u. Now this is a lot more manageable. We don't have a rule that can handle this by hand, but this is something that we can plug in the calculator if we treated u as our x. So the only thing left to do is to make an adjustment with our bounds, because if we just enter this in our calculator with our bounds of 0 and 3, we are not able to, there's a mismatch, right? Because the 0 and 3 are in terms of x, but what we want and need is in terms of u. So we're going to be converting our bounds to be in terms of u. So 0 and 3 right now are in terms of x. We're going to convert those bounds. So if x is 0, then u is equal to 2g of 0 plus 1, right? Plug into this form. 2 times g of 0 plus 1 is 2 times 5 plus 1, which is 11. And then if I convert the bound of 3 into my conversion here, 2 times g of 3 plus 1. G of 3, we look at our table here, g of 3 is going to be negative 2. So 2 times negative 2 plus 1 is negative 3. So now we have our bounds being converted. 0 was 0. Now we convert it to 11. It was 3. We now convert to negative 3. Now this may feel strange. Seeing your bounds, you feel like you may want to flip these. You could, and then just put that to be a negative, but I would really only just worry about converting bounds if I'm trying to pull something from a visual graph. I don't have a graph in front of me. I don't have to add anything with my definite integral. So this can just go in the calculator. And when I plug in the calculator, I'm just going to treat the u as my x. Okay, which is because because we have our calculator available, we can just simply plug in. So we want to make sure that we are in radian mode. 0.5 first. Math 9 will take us to definite integral. We want to go from 11 to negative 3. And then cosine of x dx, right? Even though you may be seeing other variables on paper, in the calculator you're always going to be in terms of x. And, cosine squared. So I have to be squaring that expression there. So cosine of x, parentheses squared. Let's try that again. Yeah, negative 3.464, answer choice B. All right, 34. Which of the following is equivalent to the indefinite integral of cosine 4x sine to the 5th power of 4x? So I'm going to rewrite the problem because I'm thinking this is going to be a u substitution. Also, we see some hints here, right? We see some u's, which potentially indicates that there could be a u substitution going on. So before I go through u substitution, though, I'm going to rewrite the problem, try to get my exponent to be outside my sine expression. Once I have it outside the sine expression, then I can see more clearly that maybe I can target this expression to be my u value. So I let the u value be sine of 4x. The derivative of sine is cosine of u times u prime, so cosine of 4x times 4. I make solve for dx, cross multiply, du over 4 cosine 4x. So now we can make our substitutions, right? This gets replaced with u. This dx gets replaced with du over 4 cosine of 4x. We get the cosine 4x to go away nicely for us, push the 1/4 out in front, and then we get it to match answer choice C. Okay, 35. So we're asked to find the indefinite integral of 10 over square root of 8x minus 4x squared. We see that there is a variable in the denominator. This is not going to fit nicely with u substitution. If we let the u value be what's inside the radical, the derivative will produce 8 minus 8x, and there's nothing x in the numerator here to match. So usually what happens is if the degree in the denominator is greater than the numerator by 2 or more degrees, then it's a possibility that we can explore arc trig. So if we try to explore arc trig, that means if we see square root, it can't be arctangent, right? It has to be either arc sine or arc secant. So if I get that denominator form, maybe I could get this to look like arc sine, but that means I have to get it into this form. So a squared minus u squared. I'm going to rearrange this as negative 4x squared plus 8x. I can factor a negative 4 out. X squared minus 2x can allow me to complete the square. What needs to go inside here is I need a b over 2. So b over 2 squared plus 1. Now it is a little messy here because if I factor a negative 4 out, this plus 1 is really a negative 1. So a negative 1 and a positive 1, I need a plus 1 out here as well because these will really cancel out, even though they look like they're the same sign. Now, x squared minus 2x plus 1 can factor to be x minus 1 quantity squared. And if we rearrange it, that means we can put the 1 in front minus x minus 1 squared. And now we're getting it to look more like this form with my constant in front followed by my variable second. So my a value is what's inside the parentheses. My u value is whatever has that variable in it. So a is 1, u is x minus 1, du over dx is 1. I make my substitutions, and I get 10 over 2. Right, 10 is still part of my problem here. Divided by 2 because there's a 2 coefficient out in front. And then I can push that 10 over 2 as 5, and then the rest matches my du over square root of a squared minus u squared. So the integral rule is arc sine of u over a. My u value is x minus 1. My a is 1. So 5 arc sine of x minus 1 plus c, or 5 inverse sine of x minus 1 plus c. That's answer choice C.